All right, team, so we're still in Unit 4. We're going to dive into Lesson 7 today. And this is where we get into multiplying 2 by 2-digit numbers. And so we're going to stay both in the concrete, which is place value blocks, except they're drawing them, which actually makes it pictorial. But we'll stay in the concrete and the pictorial. But the sort of like goal of today's lesson is that kids understand there are 2 digits that they're multiplying by a secondary 2 digits that they're multiplying. And so we are going to dive right into that today. I just want to re-ground us again in this standard 4.nbt.5. Multiply 4 digits by a 1-digit whole number and multiply 2 2-digit numbers using strategies based on place value. So again, what's going to be crucial today is we're doing a little bit like less of the powers of 10 consistency type of language, but the powers of 10 are very much alive and well and like knowing their base factors. So again, this is where those rolling numbers and that fact fluency is going to start to come in addition to that, attention to precision. Kids are going to be doing a lot of pictorial representation today with flats, sticks, and dots, and it's just super crucial that you push the top quality annotation and you push the top quality representations. Messy work is going to be no one's friend today, and it's going to lead to inaccuracies, and it's going to lead to low exit ticket mastery. Okay, so let's dive right in. Problem of the day, what do you know? We start with a story problem. Again, do not pass go. Every single kid must have it. Miss Bubbles is planning on having a Fantastic Friday at a movie theater. The theater has 14 rows of seats with 23 seats in each row. How many seats are in the theater? Let me do my second read. Miss Bubbles is planning on having a Fantastic Friday at a movie theater. Good for Miss Bubbles. The theater has 14 rows of seats. This language is familiar to me. I know that this is my number of groups. With 23 seats in each row, I know this is my amount in each group. How many seats are in the theater? I'm not done. My big problem is, in fact, super important. And great, so let me do my knowns and my unknowns. This is something that I just always do. I know there are 14 groups. I know there are 23 in each group. I don't know how many seats in all. And that's what I'm trying to solve for today. All right, quick representation. Remember, this is my go-to with multiplication. Number of groups times amount in each group gives me my total or my product. And I come back over to my KU chart or my tasks. Let's see, what am I trying to find today? Task 1, find total seats. So based on my tasks and based on my jots or annotations, do I have some stuff to help me figure this out? Yep, I've got my number of groups, it's 14. I've got my amount in each group, it's 23, and I'm trying to solve for the total. Okay, so here's where we go back to this idea of a place value array, but it's a little bit different today because there are 2 digits. My first digit is 14. 14 is actually composed of 1 10 and 4 ones. That's 14. 1 10 and 4 ones. And I'm multiplying that by my amount in each group, which is 23. 23 is composed of 2 10s. Do you see how today I turned my 10 sideways? It's still a stick. So I turned my stick sideways. It's just going to help me with like visualizing place value. So 2 10s and 3 ones. So now I actually have 14, 10, 11, 12, 13, 14 times 10, 20, 21, 22, 23. 14 times 23. That's actually how this sort of like area model, or sorry, this place value array is done with a 2 by 2 digit. So then I ask myself, how many groups of 10, right? Does that make sense? Or I ask myself, what is 10 times 10? Yes, so 10 times 10 is what? 10 times 10 gives me 100. What is another group of 10? Right, gives me a 100. And what about 10 times 1? Gives me a 10. 10 times 1 gives me a 10. 10 times 1 gives me a 10. So you see how I did that math? Yeah, I know, it's tricky. All right, let's keep going. I could have done 14 singles, right? And if I did 14 singles, it would be 10, 10, 1, 2, 3. 10, 10, 1, 2, 3. 10, 10, 1, 2, 3. But I didn't do that. I'm multiplying my 23 by a group of 10 and then 4 ones. That's how I got that 100. 10 times 10 is 100. 10 times 10 is 100. 10 times 1 is 10. 10 times 1 is 10. 10 times 1 is 10. That's what kids need to be asking themselves today. 1 times 10 is, 10. 1 times 10 is, 1 times 1 is, exactly. 1 times 1 is 1. 1 times 1 is 1. 1 times 10 is 10. 1 times 10 is 10. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 10 is 10. 1 times 10 is 10. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 10 is 10. 1 times 10 is 10. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Whoa! This is why attention to precision is going to be very crucial today. So you notice that I actually have two groups of partial products. I've got my products that sort of stay in the tens of things. That's one group. And then I've got my products that stay in the ones side of things. So we would ask ourselves, what am I working with here? I'm working with 100, 200, right? There's another 100. So this is sort of 200, 10, 20, 30. So that's sort of one group of things. Now let's move down to my second group. 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's sort of the second group of things. And now it's time to put my partial products together. So if I was going to add my partial products, it would look like this. 200 plus, 200 plus 30 gives me 230. So I've used this guy, I've used this guy. Plus 80 gives me 0, 0, 0, 8, 9, 10, 11. 1, carry my 10, that gives me, carry my 100, sorry, that gives me a 300 in that column. And now I'm going to use my 12. 0 plus 2 is 2. 10 plus 10 is 20. And I leave the 3 there. And so I get 322 as my total. So what's different about today is that my place value array actually has 2 parts to it. And that's what can make this work a little bit tricky. So I'm going to freeze this, and I'm going to have you just take a second and look at what you see. If I were to give myself feedback, I would definitely give feedback around like my ones on the left-hand side needing to be a bit more spread out just to ensure that kids can clearly see their rows. I would definitely give myself some feedback there. But ultimately, what we're going to see kids struggle with today is this core idea around, I now have a 10 times a 10. I now have a 10 times a 10. I now have a 10 times a 1. I now have a 10 times a 1. So again, this is a 10. This is a 10. 10 times 10, 100. 10 times 10, 100. 10 times 1, 10. 10 times 1, 10. 10 times 1, 10. Partial product, 200. Partial product, 30. And then they have to know they do the second part, right? And so I wouldn't have them total their partial products until after they've done the full array. So that is what's going on today in lesson 7. That's what kids are going to be working on. And just like, let me unfreeze and give you a quick preview of the work so you see how it all fits together. So in workshop, kids are going to need to build the place value array. And then they're going to need to solve for the partial product and give their answer. They're also going to have to draw a picture of the place value box array to match. So they'll have to do sort of both things. It actually asks for place value blocks for kids to build with. And I think that you can do that on the .cam. You don't necessarily have to put place value blocks on all of the kids' desks. I think it might be actually more of a distraction. I just want to point out there will be story problems embedded in, so the kids will need to pull out the math from the story problems. And I think this is a perfect space for kids to do a KU chart, frankly. They really do need to make sure that they have these in. So I do think there's space for them to do that. And then they should, of course, represent sort of across the top. So don't let them, just because we're looking at a different format, not do their academic habits around place value charts. Kids are diving into story problems for most of the work today. So they must pull out that KU. They must have a representation. There are a few problems. So the exit ticket itself does have one story problem, and it's also got one that's not embedded in a story problem. But just wanted to give you a heads up around that. Again, the top quality habit work expectations around story problems are